Hello, this is the start of section 3.6, Graphs of Functions. Part 1, Vertical Line Test. The vertical line test, or VLT, is used to test to see if a graph represents a function or not. If any vertical line passes through more than one point on the graph, then it is not a function. Determine which graphs below are functions by using the vertical line test. So no matter where I draw a vertical line on the first example, we are crossing the graph exactly once. So this is a function. Now for B, if I draw a vertical line right here, technically we only cross it once. But this is where the key word is any. Because for example, if I draw a vertical line here, it now crosses twice. So this is not a function. Part 2, graph of a function. The graph of a function is the graph of all its ordered pairs, x, y, or using function notation, x, f of x, where f of x equals y. As we move forward in our study, it will be helpful to be familiar with the graphs of several basic functions. Recall the domain is the set of all inputs or possible x values of the function, and the range is the set of all outputs or possible y values of the function. Below is the table of common functions in the graphs. We will call these functions parent functions. Because they are the simplest versions which we will build off of next. So you can have f of x equals c, where c is a constant. Well, this would be the same thing as saying y equals c, and we've already talked about this. This is a horizontal line at c. Now this, again, would be y equals x, but we're using function notation, so f of x equals x. This is called the linear function, and it looks like this. And then we have the absolute value function, which looks like a v. Then we have the square root function, which has a slight curve to it. Then we have the quadratic function, which hopefully you're familiar with this one from high school. It looks like a U. Then we have the cubic function, which is kind of like the U, except one of the sides is flipped. And here are our parent functions. Example 2. Find the domain and range of the following graph. Write your answer in interval notation. So the domain, you can see in red here, is the set of all x values. And it's going from -5 to 1. So our domain is -5 to 1. Again, that's because it goes from here to here. Those are all the x values. Now the range, which is in this teal-like color, goes from -4 to 2. So there's our range. Example 3. Use the graph below to answer the following questions. So I want f of 0. Well, remember, this is the x value. So if I go to where x is 0, where does it cross the graph? At 0. So f of 0 is 0. But now f of 3 halves pi. So again, I need to go where 3 halves pi is. And then where does it cross the graph? Right there. So we get -1. And finally, f of -1/2 pi. Go to -1/2 pi. Go down. That is also -1. Part B, find the x-intercepts. Well, we already have 0, 0 as one of them. It also crosses at pi 0 right there as well. So -pi 0, and then there and there as well. So 2 pi 0 and -2 pi 0. And then the y-intercept, where does it cross the y-axis? 0, 0. Here would be a good question to put on the exam. How many y-intercepts can a function have? So I'll let you ponder that for a little bit. And then write the domain and range and write your answer in interval notation. So the domain, again, is the set of all x values. Because of the arrows here, it's indicating that it's going to repeat in this pattern forever. So our domain is -infinity to infinity because it's going to go forever. But if this pattern repeats itself, the range, I'm hoping you can see, it has a low point of -1 and a high point of 1, and we can equal those values so they will be brackets. And that is the end of section 3.6.